Yeah.
Perfect.
Okay.
All right. The floor is yours.
Thank you. Hello, everyone. Probably good evening. This is Farhad speaking. I'm going to present our work, our research on high performance monitoring sensors for home computer user security profiling. It's a part of a bigger research that we are working on it to create an intelligence system to detect users' behavior, risky behavior, to understand if users doing something risky, and then provide them a better solution or some security awareness to reduce the risk of these kind of activities, especially for home computer users. So recognizing users' behavior in real time is an important element of providing appropriate information and help to take suitable action or a decision to respond to cybersecurity risks. And you know that this user's behavior or actions are usually erratic, evolving with time, and occasionally computer users behave differently due to a change in goals or purpose. For example, users do something today and that user might prefer to do something else in a week because the intentions change, because the purpose has changed. So it is important to understand what users right now doing instead of using only a history. User profiling is the process of producing a profile of user from historic information in the past details, but it could obtain appropriate and adequate and accurate information about the user interests, characteristics to demonstrate with the minimum user invention. A user security profile represent should be abstract. Representation should be actually abstract and possible to reduce the storage requirement and increase the process. So it is important to understand the minimum requirement, minimum behaviors we have to track or to capture. Then we can build the profile based on that. These researchers try to identify these monitoring factors to provide an observation solution to create high performance sensors in comparison. What we are creating we have created in this research is cross-platform. It's not belongs to any specific platform, but when it comes to implementation or solution we have provided in this research, they are created for Microsoft Windows because it has 77.7% of home computers, and the language which is used is Python. I have provided the evidence why we choose Python over other languages in this research. As I said, a user profile is a set of structured data and information to describe a user in an interactive environment between the user and the system. So common what we need to understand from a user is personal information and user data, mostly by explicit methods, user knowledge, skills, experience, user habits, user interaction preferences, user intentions, and also the most important one is the present goals. For example, the user interests and preferences should be captured via dynamical statistical model, including such as, for example, web browsing or history analysis. Users' habits and preferences could be detected to user interaction patterns based on a chain of steps or actions that the user conduct in a routine task. So this table provides how could we capture this kind of data. For example, as you see, personal data is only could only be captured through explicit models, but for others we could use both explicit models and implicit. But because we want to be transparent and with the minimum engagement of user. Most of them should be implicit model that we have described in this research. The user profiling process is a type of knowledge discovery in database, or the new model, user data discovery model. So, and it's based on two different actions: knowledge-based models or behavior-based models. The behavior-based strategy employs the user behaviors and actions as a model to observe beneficial patterns by applying machine learning techniques. These behaviors could be extracted through monitoring and logging process. This aspect drives the idea of using data science and machine learning to automate the user's behavior analysis and provide the data-driven decision-making model that we need in this particular research. One of the most important things in this research is the privacy and security of users. As we know, we are logging users' behavior and actions. These kind of data could be used to identify user and probably compromise the user's privacy. So it is important to make users sure that these kind of data would never compromise the user identity. This is very important. And also because of the GDPR law in Europe, we must be in compliance with the GDPR requirements. All these are already discussed in this paper. Yes, sorry. For this, we have three different components we have to consider. First, the user data should be protected against any unauthorized access. So first, when we log, they should be in somewhere very secure. The second thing is, in case of any unauthorized access, the user data should be protected against disclosure, for example, being encrypted. And also the third one is, in a data disclosure scenario, it's significant to prevent an attacker to identify a user from compromising data, and a system is to ensure these data are won't be used to identify user. Because of that, I will tell you when I'm going to talk about each sensor, how we do that, for example, by using making groups instead of each particular data. So that makes it impossible, or somehow impossible, to identify the user. So as a solution, here we have an observer. The observer is an agent. So this agent monitors the user activities in an interaction with the computer or online services to collect the required information and to analyze them. Each agent or sensor works independent on its local view of the environment and communicate with others to receive or provide relevant data in accordance with the precision of shared data structure. As I said, we use Python for implementing these sensors. This is a model for the observer. As you see, we have environment. Sensors monitors the environment to collect data. Then it should goes to feature extraction and assign the learning models or inference engine. And then when we need, we have to provide actions, for example, immediate alert or immediate awareness about the risky behavior. This diagram, this table provides what we need to detect and which of them could help us to understand those elements we previously discussed. So, for example, the file system and file related events could help to understand interests and preferences, habits, for example, to understand what kind of file activities. For example, if a user uses JPEG files or PSD files most of the time to create or edit, so it means these users could be a user who is using computer for graphic things, graphic activities, or for if the software installed mostly are the group of editing tools, this user uses computer for this kind of task. So this table provides an overview about what we need to collect, what kind of sensors we have, and for what reason we can use those collected information. The file system and file related events, information about the type of files on a home computer, provides information about users' job and interest, information about the type of files operations, including modification, creation, or removal of files, will also provide information about user habits and interests. The file system sensor is formed of 3 components. The first component provides information about system partitions, for example, including each partition file system, if there is any encryption method is enabled on that, if that partition is a removable partition. The second component comes on all files and file types on the system, particular folders. So here we have to exclude some folders, for example, on Windows, the Windows folder or user folder, some kind of these common folders, to exclude them to make sure that we only count files the user use, not the system files. The third component analyzes the file changes. It observes any file interrupts and classifies any created, modified, or deleted files. This model you see here is a JSON export that tells us about the file system sensors. If there is any NTFS, if all partitions are NTFS, one means, yeah, all partitions on this computer are NTFS. If there was any removable media in last 24 hours, or if there was, all partitions were BitLocker or NTFS, but no one had BitLocker enabled on them. And here in file type, you can see, for example, 19% of files that the user was using is programming files, C, assembly, Python, this kind of thing. So probably this user is a developer user. Installed software is a list of all installed services and programs needed to understand potential vulnerabilities and also security measures. This list also determines what security or privacy software is already installed and updated, so it helps to identify the user knowledge or computer skill. For install application, firstly, it requires to obtain a list of all applications. To protect user privacy, as I said, and to analyze the application, we only need to understand which category each application belongs to. We don't know what exactly application is installed. We only need to understand what category that software belongs to. For example, is that the audio software? Is that the security software? Is that the user? So for this, to categorize users, we used CNET as the reference, as an example, to understand which application belongs to which group. It is necessary also to compare the list of installed application with the reference list, as I said, from CNET. For this, we had to use, and you know, when different version of software, different applications register with different names and different operating systems, so it was very difficult to understand the real name and compare it with the reference list. So we had to choose a high performance tools to analyze the names with the reference list. We tried Jellyfish, Spurs.top-N, TF-IDF dig, TF-IDF. All these we analyzed, and as it is already presented in the paper, TF-IDF had the most and the best performance in on analyzing these software. So installed software, JSON exported from the installed software sensors provides the first the category of applications already installed, and the second one is the special categories. For example, more than knowing if a user uses mostly audios or security software or utilities, we need to know if the user has already installed password manager, if the user has installed firewall, remote access, or file sharing, these kind of things, because this gives us information about some vulnerabilities, if the user is vulnerable to these kind of things or not. Another thing is running application, another sensor is running application and services. It's also significant to understand the program popularity by collecting information about how many times and for how long each application is in use by recording start and termination process time. This information is very beneficial to understand users' interests and habits, and also could prioritize such as security and privacy work. It also provides information about using security applications such as backup tools, which demonstrate the user's scale. It makes it also possible to detect user risky behavior by identifying dangerous or unnecessary application or services. For example, if a user uses file sharing application on his computer. Analyzing running process does not provide us with too much information, because many applications or services might be run in the background, but user doesn't use them. So it is necessary to identify the active window, the application user really use. For that, we need to identify the active window. Each application has a dedicated window link to the application name. So the active window is the application that user currently in use. So therefore, it is necessary to capture the active window frequently. In this system, we use 10 seconds, every 10 seconds, and then calculate the total time of usage for each application in this period. This export JSON provides information about the running process. Again, just like the file types and applications, this only provide us the category, not the name of applications users use. So it's not such an identifiable information. So it's not possible to detect who is the user from this information. Sorry. Another sensor is warning and security events. So system warnings and security related events along with the user response should be captured to discover user skill and also the knowledge to understand relevant security vulnerabilities of threats. This sensor should collect information about critical errors and warnings generated by the operating system, or those applications log their data inside the OS log system. For this information, it is necessary to access the file system log and collect and analyze those log information. For example, in the last 24 hours, in the last week, this kind of thing. So we only collect, it's optional to collect only the warnings or also the critical information based on the OS we are using. In Windows, we use system warnings and criticals. Another sensor is the network traffic. The network sensor should gather information about several requirements. The first component in this system should collect information about open ports to detect the vulnerabilities. If any vulnerable port is open on the system computer, this component should identify. Yeah, and of course, this is important to update this port. So when we want to do that sensor, we need to update the sensors frequently to make sure it has the up-to-date list of open ports, vulnerable open ports, I mean. The second component should identify unsecure and public Wi-Fi connections. For example, if a user connects to a public Wi-Fi, you see in the export here that in the last 24 hours, the user had connected to a public Wi-Fi. So this is one of those options that system requires to take an action immediately, because it's a very obvious risky behavior, and user should be understand the risk of this action. The third component is the network interface analyzers. This component should determine the network usage, interface usage, including if the user is mostly connected to wireless LAN or using a VPN connection, or if the user works mostly from home or from work location. So it could provide information about how much time the user spends on each interface. So to understand the work and home usage, we can use IP location and analyze these IP locations, but because of the GDPR, we prefer to use an explicit model, and each time user connects to a new network which is not identified by system previously, it asks user if it is work or home access. The next one is the internet browsing history. Web browsing data such as visited URLs and time spent on each website is usable to understand users' online habits and interests. So this helps to discover potential threats and might help to reduce the risk of vulnerabilities and risky behaviors in social networks. Every website is visited is recorded along with the start and stop time. For the implementation, we used again an add-on for Google Chrome. This sensor should detect the categories of visited websites, again, because of the GDPR and privacy of user. This extension detects URLs and the time spent on each URL. This information will be saved in a temporary memory, and the agent gets access to this file for frequent to categorize users. We use the websharing.com to categorize the URLs each user uses. And the last one is the system setting. So it is also important and is a key to understand the environment that user is working on. The OS name, the current version of the OS, if it's updated or not, the owner, if it's organization computer or the home computer we have here, if it's a laptop or it's a desktop computer. This kind of information helps to understand more the security vulnerabilities this user face to. So the OS setting sensor needs to identify computer type, OS version, if user accounts, multi-user accounts is enabled, if any shared folder is enabled in this system. Also, it requires to understand the latest update which is installed on this system to understand if user use OS update. Any integrated firewall or malware detection system also should be identified on this. And also, it requires to understand if user has, for Windows, enabled the Find My Device, or the user uses any webcam. So, for example, having a webcam might compromise the user privacy. So it's important to understand if there is any security risk on this as well. In conclusion, the primary function of the user profiling is capturing users' information about the security actions and security behaviors. This information might be used to understand more about the individual's knowledge, skills, to improve the security and privacy by providing necessary awareness security tips. So this research proposed implementation of observation method, but yeah, the future research could be using machine learning methods or data mining techniques to analyze this information provided or collected by these sensors to provide the necessary security awareness and tips. Thank you very much. I'm not here to answer any question if there is.
All right, Farhad, thank you so much for this talk. So we've got a couple of questions. The first one is from Tapadir Das, and he asked, can you please distinguish between explicit and implicit models regarding the user profiles?
So implicit model, explicit models are those models that ask users questions about that. For example, if we use user to interact, for example, what I said about the home, if the location is home or work, we have to ask user to tell us about if it's a home location or it's a work location. But when we do something transparently without user interaction, that's an implicit model.
All right, and then we've got one question from Tolga Onlu. Are you planning to also looking into the instrumentation of application? For example, monitor whether an application makes suspicious Windows API calls. Basically, this could be used to create benign execution profile of a user application.
Yes or no. Our research now are focused on, as I said, to use machine learning techniques and data mining to analyze these kind of things and create a software as an instrument to detect these kind of things on the home computer users. The prototype is, we are working on the prototype right now, but no, not as an API. In the next, in the future, we have to also compare users together to understand more and more about these risky behaviors, but not as an API right now.
All right, and then our final question from Mohammad Saidi. Many thanks for your talk. What is your implementation environment or test bed, and have you created the data set?
The data set is in progress right now. Yeah. As I said, right now, the solution is independent from any operating system, but what we have already implemented is Windows-based, and we use Python language to create the sensors. So, but yeah, the solution is independent from any operating system.
All right, Farhad, thank you so much for this talk. And we don't have any more questions. So
Thank you very much.
Cheers.